So I'm Fahad Ahmad. I lead data science at Halliburton Digital Solutions. Halliburton is a oil and gas service company. So what we do is we provide services to our customers in all the stages of a oil well life cycle. And we gather a lot of data. And so one of the things that started, it's a 100-year-old company. We have 13 internal business units. They operate fairly independently. And like I said, we capture a lot of data, but because the systems have evolved independently, it's a big challenge to access the data from these disparate data sources. So about 4 years back, we started on a journey where we tried to centralize all the data in a central data lake. And I lead data science, but all the cool things that are happening with AI, LLMs, RAG, your models and all these pipelines are only as good as the data that you bring to them, right? So we quickly realized that we need a very good, scalable, robust data foundation. And so that's how I got pulled into all this, and now I oversee both data science and the data platforms that we are building. So going back, right, 4 years back, there was an initiative to centralize all the data. And as you can see, we generate a lot of very high frequency sensor data anytime we perform operations in the oil field. And all that data is converted into Parquet files and stored in the data lake. The problem with this was, it's a very big company, like I said, lots of different disparate data sources, and there's always pros and cons of centralized versus the decentralized approach. And I think previous sessions had talked about this in much detail, so I'll go over this very quickly. Centralized approach works very well if you have like a small organization, right? Think about like a small doctor's office, lawyer's office. Everyone speaks the same language. They all understand the data. So it's good and it's cheap, right? For a company like us, it didn't work very well at all, because the problem was this: even though we are capturing all the data successfully in a central location, there was hardly any consumption of the data. And the people who were consuming the data, whenever they used to see issues with the data, they didn't know who's responsible for fixing those issues, right? So the ownership wasn't clear. And as a result of that, the data quality was really suffering and the consumption kept dropping. So then we started working with Starburst about a year and a half, I would say 2 years back. We learned about data mesh, data products. So then we started evaluating whether we should be adopting data mesh. And clearly, as I have listed here, there are benefits of using the data mesh approach, right? The main thing is you're treating data as a product. So what it means is, instead of one central team trying to figure out all the issues with the data, you shift the responsibility of the data quality and the ownership to the people who know the business and the data, and then let them handle and provide those guarantees and consistent interface so that the consumers, when they consume the data, they have some level of confidence. And also, when something happens, there is a team or a person who takes ownership that, yes, I understand the issues that you're facing and I can go back and fix it, right? So that was the main benefit of data mesh, right? So this slide is just asking questions whether we should accept. We went through this exercise about a year and a half back, but a lot of organizations, they ask the same kind of questions, right? Whether we should adopt data mesh. And as you can see, there's the situation where we were in checks a lot of boxes, but the final two are actually, again, just highlighting it, and they're important, which is, and I have heard similar stories from other organizations also, which is, again, it's a cultural change, right? People need to be ready to accept the fact that your responsibilities are now not on a central team, rather you are pushing it to like a decentralized ownership model where each team is responsible for curating and surfacing their data, right? And because of that, there was the other issue where there are not very clearly defined data roles, right? So each team needs to have a data steward, data owner, and then they need to have some data engineers who understand the data, who understand the business, and they are able to curate and surface the data. So we started working with Starburst. We started building data products, right? So this is how our mesh looks like. So like I said, we have 13 internal business units. They operate fairly independently. The yellow circle in the middle, that's what my team is responsible for. So we have built a shared infrastructure. There's multiple domains, as you can see here, and each domain can have several nodes. By node, I mean data sources, right? And these data sources or nodes, they can be on-prem, they can be some relational data sources on a cloud like Azure or AWS. They can even be NoSQL systems. They can just be Parquet files on a blob store, right? But because of the Starburst layer, everything looks like a consistent, like a logical warehouse, right? Everything looks like a table, you can query it like a table. So that's what we get from using Starburst, which is this, what data virtualization layer, single point of access. And on the right, you see all those purple boxes. Because of this consistent interface, now everyone is seeing the same view of the data, right? So whether it's your data scientist, whether it's your, BI dashboards, your mobile apps, your web apps, and then finally your ad hoc queries. So now we'll talk a little bit about the interesting part. So I went fairly quickly about the data mesh, data product side because you have already heard about all the benefits before. So now LLMs, right? So this ad hoc query piece. So here's what used to happen. And I think you can relate and it resonates with most of the people here is business has a question. You go and ask someone that, hey, what were my sales numbers last quarter, let's say, for example. From the time that question is asked to the time you get an answer, that's easily 3 to 4 weeks. And what usually happens is you'll take the question, you'll actually then go to a data scientist. A data scientist would start, sourcing the data. They would try to figure out, hey, who's the owner? How can I get access to the data? They would move the data somewhere, maybe in Databricks. They would do some, analyzing, data cleaning, joining, aggregations, all that in PySpark, Python, whatever. And then finally they'll come up with an answer. And once you come up with an answer, right, the business will come back with a slightly different question. And now you have to repeat the same process again and again. So you can't really, it's not a scalable system, and just the lag between when a question is asked and when the business gets an answer, that was just not acceptable. So we wanted to build an interface where people can just come and ask questions in natural language and get an answer immediately. So think about humans, when we talk to other people, right? We don't talk in keywords or SQL language. We just talk in plain English or any other language, right? Why can't we do the same thing with our data? I want to just ask questions in natural language of our data, right? And that's what we have tried to do. That's our vision. And this slide is a little busy, but what we did was with Starburst, we have a very clearly defined data products layer. So each data product describes the purpose, the ownership, what it does, and then it has a well-defined schema, and it has the descriptions for each of the fields in those tables, and and the platform is self-service. So the producers of the data can go and actually enrich the metadata for each one of those tables, right? So now when a user comes in and asks a question, right, very simple in natural language, we call the Starburst APIs For the data products, we get the full schema, right? The table name, the description, the purpose, and the description of each one of those columns. We package the query along with this extra information that we got, and we send it to an LLM. The LLM takes all of that. It still doesn't see the data. That's the key point. No one is seeing your data. I think this, obviously privacy and security concerns. All it sees is the schema. And then it generates a SQL. And because we have a very standard, consistent, single point of access, we can take the schema and run it against the data product on the fly, right, live, and get back an answer. So that's what I've tried to explain in this architecture diagram, which is, you just send your query, converse in natural language, convert it to SQL, and get back the answer in real time. Okay, so demo time. Hope it works. So this is how our data marketplace looks like. So each tile is a data product, right? It connects to, it's tied to a domain, connects to a single node in the mesh. I can go and search for things, right? Each tile describes what the data product does. I just search for a column name. It gives me the tiles which have that information. I can go and preview the data, right? And this is what I was talking about, which is self-service. You can go and add more descriptions for each one of those columns. Now, I can write a simple English query, right? And then what I do is I take the query, I take the schema and the descriptions and everything, I send it to LLM, and then it generates this SQL. And I take it, run it live, and I get the answer. Then we have also added some data science functionalities. You can do some chartings, visualization, those kinds of things. You can copy it, put it in a PowerPoint and whatnot. So that's our data products and GenAI, leveraging LLMs to answer questions in real-time platform. Hopefully it made sense, and I'll take questions later. So now here's the thing. Here's the enhancement, right? So you're taking your user's query and you're generating SQL in real time. But what if the SQL does not understand, or the large language model, which is generating the SQL, does not understand your internal jargon? And this happens all the time. You can go and enrich the metadata as I showed before, which is, let's say if you have a low cardinality column, right? You can just say this column contains, these three different, categories of, whatever, lab locations or anything else. But there's limited value. I mean, certainly do that, but there's still you'd quickly hit the capacity of how much humans can go and annotate the data. We have thousands of tables. Each table has hundreds of columns, right? So it's very tedious, very time consuming for a human to go and annotate all the data, all the columns properly. And most of the times your columns are abbreviated, right? So for an LLM to generate the right SQL query, it needs that extra information. So what can you do here? So this is an interesting example, right? So we have a product called Zeus, which is basically used for electric fracking, but no one outside the company will know. I mean, some people will know. I mean, it's public information, but still, an LLM trained on public data will not know that Zeus and electric fracking are the same thing, right? So what can you do so that your prompt are augmented with this extra information and sent to the LLM so that the LLM can generate the right SQL query? So what we did was, and a lot of people have talked about RAG. I don't think I have time to go into RAG right now. It would take another hour. But what RAG allows you to do is, add domain data to your prompt and look at all the unstructured data inside the company to come up with an answer, right? So basically, you're grounding the answer or the output of the LLM to your domain data sources. So that's what we did. So now, when we do that, when a query comes in, what we do is we call this RAG pipeline, which understands our internal jargon. And then we also fine-tune. So RAG is basically works on semantic similarity, right? So you have embedding models which basically know that these two things are close to each other in the vector space. So we fine-tune the embedding models on internal corpus or our internal document corpus so that it starts understanding our internal terminology, jargon, all those things. So now, if you see here, right, the interesting thing which happens is if you just go to a open source foundation model, embedding model from Hugging Face or OpenAI, Zeus and electric factoring are not very close in the vector space, but once we fine-tune the embedding model, it actually comes a lot closer, right? And that's what we want. We want them to have a higher cosine similarity. And then, so when the query comes in, we go to this, and then all this internal data is actually indexed and stored in a vector database. When a query comes in, we go to the RAG pipeline, we retrieve the relevant context, right, from the vector database, we feed it to a LLM, it comes back with an answer. And now we take this extra context and append it to the user's question. And something very interesting happens. So on the left side, you see no RAG. All I do is ask a question. Hopefully it's clear. It generates some SQL. Actually, that SQL is not wrong, but it's not completely correct. And so because of that, I don't get the correct answer. Okay. Now, if you see the green part, all I did here was when a question asked, right, how many alerts did we generate due to electric fracking, I go to my RAG pipeline and I ask, can you describe electric fracking? Or you can be creative how you want to do this, how you want to augment it. But you go and call this RAG pipeline, which will retrieve some extra information about what electric fracking inside your organization means, right? In this case, it's Zeus. And all I do is I take that extra text which the RAG pipeline gave me back, and I append it to the question. So I ask the same question, but you can see the difference, right? All I did was added this extra couple of sentences. So now what happens is if you look at the SQL, it's slightly different. But that's the SQL I was looking for. And like I said, you could do the same thing with going and manually annotating the data, adding more column descriptions and whatnot, but it gets very, very tedious. Here we have used another LLM to actually augment or help refine a user's question and add extra information so that it generates the right SQL. And once I have the right SQL, I go to run the Starburst SQL against the Starburst data product and get the right answer back. So that's what domain-aware prompting means, which is basically now just instead of using a publicly trained LLM to generate the SQL, you are feeding it extra information internal to your organization, right, related to your domain, and asking it to generate the SQL. And it works a lot better, right? So there were some talks before that we want AI to do the boring work, right? We don't want AI to do the exciting. And this is a good. It's not completely boring. I would say boring and exciting. I would say somewhere in the middle, but it's still very, very tedious and time consuming. And in fact, here AI has helped us to do that and add extra context or extra augmentation of the prompt, which gives me the right SQL. So that's my talk, and thanks everyone for listening. Thanks, for giving me the opportunity to present. Yeah, happy to discuss more. You can shoot me an email or add me on LinkedIn. Thank you.